Today we're going to be talking about sedimentary rocks, and sedimentary rocks are formed from weathering and erosion. So as these rocks break apart, they get moved by either water, wind, or ice, and they're transported down from usually mountains where they erode into a depositional environment, something like a lagoon or a sand dune, where they'll settle and then eventually become buried and they lithify. So we have weathering and erosion, transport, deposition, and then lithification when it turns into a rock. So weathering and erosion are an important part of this process because all rocks have to weather into a sediment small enough to be transported, right? So to be transported, the smaller particles travel a lot further with a lot less effort. So if you can imagine, small particles such as sand can get blown through the wind, whereas larger boulders end up staying close to where they came from. So you have sand dunes and even like dust particles traveling all over the world. And then you have the larger particles that can only get moved by large forces like big rivers. So if you can imagine, like a river here in Clemson is going to be mostly muddy, small sand grain particles that had to move pretty far from the mountains upstate in South Carolina. And then maybe in the mountains, you know, you go to a river and it'll be waterfalls pushing pretty large boulders around. So when you get asked in your lab about how stuff forms, remember upstate, larger boulders, that's about as far as they can get. But then farther down the coastal plain, we have tiny grains of sand getting moved by wind and even clay particles that are moving through the water. So we have three categories of sedimentary rocks that you're going to have to be able to identify for this lab. And we have our clastic rocks. So those are rocks that have been kind of stuck together and cemented. They can look pretty obvious, like big gravel stuck together in a conglomerate. Or it can be pretty unclear, something like a shale, which will just be kind of like, you know, roof tiles. And that's flat clay particles that are imperceptible to your eyes that have been cemented together. A key with this, though, is with shale, you can kind of tell by the layers that this was a clay that had settled into a lagoon or something and slowly being put together. Our next type of rock is a chemical rock. This one's a little bit more confusing. Chemical rocks are usually rocks that have been in water and they've dissolved and then they've been allowed to reform. So something like a crystal is almost always going to be a chemical rock. And if you can't see any sand grains, if it's a smooth rock, it's probably a chemical rock because it was allowed to form in that water. Now, our last and probably most confusing category is a biogenic rock. Biogenic rocks are rocks that are chemically based off of something that was living. So you can imagine like a coal would be a biogenic rock. Or here we have this stalactite. And a stalactite is formed from calcium carbonate. Calcium carbonate is what shells are made out of, right? So here's another form of calcium carbonate in the form of a limestone, a fossiliferous limestone. This is slowly dissolved into this. So you might mistake this for a chemical rock, but this stalagmite, stalactite, and this fossiliferous rock are both made out of biogenic materials. So these are two examples of biogenic rocks. And then we also have coal. I'm going to leave you with a map of upstate coastal plain and offshore South Carolina, because some of you may not be familiar with the area. But the key thing to notice is upstate is, remember, where those mountains are, so those larger particles travel, something like a clastic conglomerate. Coastal plain is something where maybe sand could travel, and then our offshore area is the farthest away, right? So the smallest particles travel the farthest. So those are probably like clay particles that would form a shale or something like that. All right, before we get started with the examples, I just want to show that samples 41 fizzes on sample 41 fizzes under acid. It's hard to tell. And then sample 40 also fizzes under acid. I'm going to run through some just sample rocks that you don't have, just as an example of how to run through this process. So the hardest question for you is going to be question 1. What kind of sediment was the rock made from? So we have three types. We have our clastic sediments. These rocks are made out of lots of little rocks, and they can be anywhere from the size of a piece of gravel to a size of a grain of sand. A good hint with this one is that sand literally rubs off of it. But if you feel a sandy texture, more than likely that's a sandstone or something clastic. Our second category is like a chemical rock. These are rocks that have essentially been dissolved into a liquid and then recrystallized. So this is actually a biogenic rock right here, but a lot of your smooth rocks, keyword smooth rocks, don't have any class, right? So that means they've probably been dissolved in a liquid and recrystallized somehow. And then our third category is our biogenic rocks. So biogenic rocks, this one's a pretty obvious one, but biogenic rocks usually have little pockets and they fizz. And the pockets are usually some sort of seashell that's been left over in the rock. And a lot of the times they're heavily dissolved, unlike in this fossilized sample. So biogenic rocks always fizz. So for question 1, clastic rocks made out of small pieces of other rocks. Chemical, they're going to be smooth usually, dissolved in some way, and recrystallized. You can kind of imagine that. And then biogenic rocks, they'll fizz under acid, or maybe you'll be able to see a little bit of a hint of a shell or a little pocket that looks like maybe the inside of a shell. Kind of like this texture, right? So there may not be fossils, but you may be able to see little indentations. Moving on to step 2. What is the dominant grain size? Well, if you remember on this guy, you can see these grains of sand, right? So that one has a sandy grain size. And then obviously you have your gravelly grain sizes, little pieces of gravel larger than a millimeter. And then one of the harder ones is some of them have a silty or clay texture. And those are rocks where you can't really feel any sort of grit to them. They'll feel fairly smooth. Imagine something like a slate. Now, the other question they'll ask you is how rounded is the gravel? So with our rocks with pieces of gravel in them, they might have rounded stones or sharp stones. One of those is formed in a riverbed where they get smoothed off, and the other one is formed in a landslide where they don't have time to get smoothed off, like the riverbed, right? So for question 3, just remember the rock might be pretty sharp itself, but the clasts inside of it are pretty round. And step 4, probably the last question you could get confused on is how are the grains aligned? This rock, is a little bit smooth and flat. So you could say this has a flat lined texture.